Have you ever pondered about the fate of our home galaxy, the Milky Way? This swirling mass of stars, gas, dust, and dark matter is more than just a pretty sight on a clear night. It's our cosmic address, the celestial neighborhood that we, as a species, have called home for all of recorded history. The Milky Way, a barred spiral galaxy, is just one of an estimated 2 trillion galaxies that populate the known universe. But there's something unique about our galaxy, something that sets it apart from the cosmic crowd. Our Milky Way is on a journey, a celestial voyage that will significantly shape its future, and by extension, ours as well. Scientists, armed with the principles of astrophysics, are able to look into the future of our galaxy. By studying the motion of stars and galaxies, they can predict the trajectory of the Milky Way. Picture it as a grand cosmic dance, with the Milky Way and other galaxies spinning and swirling in a ballet choreographed by the laws of physics. Currently, our galaxy is moving through space at an estimated speed of 500,000 miles per hour. But where is it going? What's the final destination? Well, it's not so much about a final stop, but rather a monumental encounter. Our galaxy is on a collision course, a fateful meeting that will dramatically reshape the Milky Way as we know it. This isn't a cause for alarm, though. The timescales we're talking about here are astronomical, spanning billions of years, but it does give us a sense of our place in the universe. A humbling reminder that we're part of a dynamic, ever-changing cosmos. As we delve deeper, prepare to embark on a cosmic journey that spans billions of years. A journey that will take us from the familiar night sky of today to a future where our home galaxy will look very different indeed. Let's set off, shall we? Astrophysics may sound intimidating, but it's simply the science of understanding how the universe works. At its core, it's about decoding the cosmic language written in the stars, galaxies, and nebulae. It's about understanding the fundamental forces that sculpt the universe's grand architecture. Let's start with the basics: gravity, mass, and energy. Gravity is the invisible force that pulls objects towards each other. It's the reason an apple falls from a tree. And it's the same force that keeps planets in orbit around their stars. It's the cosmic glue that holds galaxies together. Mass, on the other hand, is simply the amount of matter in an object. It's what gives things weight. But in the universe, mass does more than just make things heavy. It warps the space around it, creating a gravitational field that pulls other objects towards it. This is why stars and galaxies form as matter clumps together under its own gravity. Now, energy. Energy is the capacity to do work, to cause change. It comes in many forms, from the kinetic energy of a speeding asteroid to the radiant energy of a glowing star. Energy can neither be created nor destroyed, only transferred or transformed. This principle, known as the conservation of energy, is a fundamental law of nature. These three concepts, gravity, mass, and energy, form the backbone of astrophysics. They govern the movement and behavior of celestial bodies, from the smallest asteroid to the largest galaxy. They explain why stars shine, why galaxies spin, and why the universe is expanding. But astrophysics is not just about understanding these forces. It's about using this knowledge to predict the future of the cosmos. By studying the motion of galaxies, astrophysicists can forecast their trajectories billions of years into the future. They can predict when galaxies will collide, merge, and transform. With these basic principles of astrophysics, we can start to understand the eventual fate of our galaxy. It's a journey of discovery, a cosmic voyage into the unknown, and you're invited to come along for the ride. You might be surprised to learn that galaxies, like cars on a highway, can collide. Just as two cars speeding towards each other on a road are bound to crash, galaxies too, under the influence of gravity, can experience a similar fate. Once they get close enough, the gravitational pull between them becomes irresistible, leading to a spectacular cosmic event known as a galactic collision. Now, you might be wondering, how can something as vast as a galaxy collide with another? To understand this, we need to delve a bit into the concept of gravity. Gravity, as you might know, is the force that pulls everything towards everything else. In the case of galaxies, it's the combined gravity of all the stars, dust, gas, and dark matter within them that pulls them towards each other. When two galaxies start to feel each other's gravitational pull, they begin to move closer. And as they get nearer, their mutual gravitational attraction strengthens, pulling them together even more. This leads to a cosmic dance, with the two galaxies spiraling around each other, slowly but surely getting closer and closer. Eventually they collide, merging into a larger, even more beautiful galaxy. You might be wondering, how often does something like this happen? Well, surprisingly, galactic collisions are not a rare event in the universe. In fact, they're quite common. As we speak, there are countless galaxies out there experiencing this cosmic dance, spiraling towards each other, ready to collide and merge. The Hubble Space Telescope has even captured images of these imminent collisions, showcasing the breathtaking beauty of these cosmic events. It's fascinating, isn't it? The universe, with its billions of galaxies, is constantly moving, changing, evolving. And these galactic collisions play a crucial role in this cosmic evolution, helping to shape the universe as we know it today. So, with billions of galaxies out there, what are the chances of the Milky Way colliding with another galaxy? Our nearest galactic neighbor, Andromeda, is on a collision course with the Milky Way. This statement might sound a bit alarming, but don't panic just yet. There's a lot to unpack here, so let's dive right in. The Andromeda Galaxy, our closest spiral galaxy neighbor, is currently about 2.5 million light-years away from us, and it's hurtling toward our Milky Way at a speed of roughly 70 miles per second. That's faster than a bullet fired from a gun. But even at that speed, it's going to take about 4 billion years for the two galaxies to meet. Talk about a slow-motion collision. So, how do we know this is going to happen? Well, scientists use a combination of observations and complex mathematical models to predict the motions of galaxies. They've been watching Andromeda for a long time, and they've noticed that it's getting closer. Additionally, they've studied the gravitational forces at play and have concluded that a collision is inevitable. But here's the twist. When we say collision, it's not like a car crash or a demolition derby. Galaxies are mostly empty space. The stars within them are so far apart that when galaxies collide, the stars don't actually smash into each other. Instead, they'll pass right by each other, like ships in the night. However, the gravitational forces involved in this dance will dramatically distort the shape of each galaxy. Over billions of years, the two galaxies will merge, their stars and gas swirling together to form a new, larger galaxy. It's a process that's as much about creation as destruction. But don't pack your bags just yet. This collision might not be as catastrophic as it sounds. And that's the beauty of it. Galactic collisions, while sounding violent and destructive, are a natural, even essential part of the universe's evolution. So sit back, relax, and enjoy the cosmic ballet that's playing out on an unimaginable scale right above our heads. The show's only just begun. When we think of collisions, we imagine destruction, but in the case of galaxies, it's more like a cosmic dance. A dance that takes place over billions of years. Let's delve into what happens when galaxies collide. Imagine two galaxies, drawn together by the irresistible force of gravity. As they approach each other, they begin to interact, their shapes distorting under the influence of each other's gravity. This is the beginning of the galactic dance. But wait, with all these stars whizzing around, doesn't it get a bit crashy? Interestingly enough, the answer is no. You see, the distances between stars are so vast that the chances of direct collisions are incredibly small. For perspective, if our solar system were the size of a coin, the nearest star system, Alpha Centauri, would be about 2 football fields away. So, when galaxies collide, it's not a demolition derby. It's more akin to a ballet. And what a ballet it is. As galaxies interact, the gravitational forces at play can cause stars to be flung out in long tails or streams, creating stunning cosmic structures that can stretch for hundreds of thousands of light years. Over time, the galaxies start to merge, their structures blending and reshaping into something new. This process isn't quick, though. It can take billions of years for two galaxies to fully merge. But what about black holes, you might wonder? Galaxies often have supermassive black holes at their centers. When galaxies merge, so do these black holes. Over time, they spiral towards each other, eventually merging in a cataclysmic event that sends ripples through the fabric of space-time itself. These are known as gravitational waves, and they're one of the most exciting areas of astrophysics today. So, rather than a violent crash, the collision between the Milky Way and Andromeda will be a slow and majestic dance of stars. A dance choreographed by the fundamental forces of the universe, playing out on a stage billions of years wide. A dance that we, from our tiny corner of the cosmos, are privileged to watch. After the collision, the Milky Way as we know it will cease to exist, but in its place, a new galaxy will form. This is the natural order of the cosmos, a cycle of birth, death, and rebirth on a grand galactic scale. So, what happens when our Milky Way and the Andromeda Galaxy, after their cosmic dance of gravity, finally merge? The immediate aftermath of the collision will be chaotic. Stars and gas will be flung into new orbits, creating a wild, irregular shape. But don't worry, the chances of individual stars colliding are astronomically small. This is due to the vast amount of space between stars within a galaxy. Over time, however, gravity will begin to pull everything back together. The merged galaxies will start to settle into a new form. This won't be the spiral shape we're familiar with. Instead, the post-collision galaxy will likely be an elliptical one. Elliptical galaxies are one of the main types of galaxies we see in the universe. They range from nearly spherical to highly elongated, and they can be much larger than spiral galaxies. Unlike spirals, they lack distinct features like arms or a bulge. Instead, they have a smooth, featureless light distribution. This new galaxy, born from the merging of the Milky Way and Andromeda, will be a unique celestial body. It will be larger, possibly containing over 1 trillion stars, and it will be an elliptical galaxy. During this process, new stars will form from the gas and dust stirred up by the collision. Others will die, their materials return to the interstellar medium to possibly form future stars, planets, or even life. This is the nature of our universe, a constant cycle of creation and destruction, on scales so vast they boggle the mind. We're not just spectators in this cosmic ballet. We're participants, albeit tiny ones, in the grand procession of the cosmos. It's a cycle of cosmic destruction and creation, and we're just a small part of it. You might now be wondering, what's going to happen to our solar system when the Milky Way collides with Andromeda? Well, let's delve a bit into the possibilities. It's important to remember that space is vast, and the distance between stars is incredibly large. So even though we're talking about a cosmic collision on a grand scale, it's not going to be a demolition derby with stars smashing into each other. So what does this mean for our solar system? The most likely scenario is that we'll be flung into a different part of the new galaxy formed by the merging Milky Way and Andromeda. As our galaxy spirals towards Andromeda, our solar system could be pulled from its current location and thrown into a new region of space. But don't worry, it's not as dramatic as it sounds. This process would happen over billions of years, a slow drift rather than a sudden lurch. And what about our sun and the planets? Well, they're likely to stay together. The gravitational bond keeping our solar system intact is strong. We're more likely to witness a change in our cosmic neighborhood than a breakup of our solar system. Now, there's a small chance that our solar system could come a little too close to another star during this galactic shuffle. But even then, the likelihood of a direct hit of another star colliding with ours is incredibly slim. Space, remember, is vast. The distances are mind-bogglingly huge. So while the night sky might look dramatically different in 4 billion years or so, with new constellations and a much brighter galactic center, life on Earth, if it still exists, will likely continue to spin around the sun just as it does today. While the view of the night sky might change, the chances of a direct hit to our solar system are slim. This cosmic dance of galaxies gives us a unique perspective on our place in the universe. As we delve into the spectacle of galactic collisions, it's hard not to be humbled by the sheer enormity of the cosmos. Each galaxy, a swirling mass of billions of stars, gas, and dust, is but a small player in an unfathomably vast cosmic theater. And yet each collision, each merging of galaxies, is a significant chapter in the grand narrative of the universe. These galactic events, monumental as they are, teach us invaluable lessons about the universe. They remind us of the universe's dynamic nature, its constant state of flux. Nothing is still. Stars are born, they live, and they die. Galaxies collide, merge, and transform. This ceaseless cycle of creation and destruction is the universe's heartbeat, a rhythm that has been echoing for nearly 14 billion years. Yet in this vast expanse of time and space, we find our small but significant part. We, inhabitants of a tiny planet orbiting an average star in the outskirts of the Milky Way, are made of stardust, the remnants of stars that exploded billions of years ago. We are, in a very real sense, children of the cosmos. And as we gaze upon the heavens, we are the universe contemplating itself. This cosmic perspective isn't just about feeling small in the face of the universe's immensity. It's about recognizing our connection to the cosmos, our shared heritage with every star in the night sky. It's a reminder that we are not separate from the universe, but a part of it, born from it and destined to return to it. These galactic collisions, then, are not just distant impersonal events. They are part of our story, a chapter in our cosmic journey. And as we continue to explore and understand the universe, we write our own small but significant chapter in this grand cosmic narrative. Even as galaxies collide and reform, the universe continues its endless cycle of creation and destruction. So there you have it. The fate of the Milky Way isn't quite as dire as it first seems. We started our journey by looking at our home, the Milky Way, and pondering its fate. We learned that despite the impending collision with the Andromeda Galaxy, the event isn't as catastrophic as it sounds. Yes, it's a colossal event on a universal scale, but not a destructive one, as galaxies are mostly empty space. We then delved into the basics of astrophysics, a complex yet fascinating field. It's the science that serves as the foundation for understanding the mechanics of our universe. It's through astrophysics that we can comprehend the movements and interactions of celestial bodies, including galaxies. The highlight of our discussion was the concept of galactic collisions. A dramatic term indeed, but as we discovered, not quite the calamity one might imagine. When galaxies collide, it's not a clash of stars, but a gravitational ballet that can span billions of years. The stars and planets within the galaxies don't crash into each other. Instead, they get reshuffled, forming new cosmic patterns. We also examined the future of our Milky Way as it merges with Andromeda. This event, set to occur in about 4 billion years, will result in a metamorphosis rather than a demolition. The outcome? A new elliptical galaxy born from the fusion of two spiral ones, a testament to the dynamic nature of the cosmos. Finally, we pondered our place in the universe. Amidst the vastness of space and time, our existence may seem insignificant. But as part of this cosmic maelstrom, we're given a front-row seat to the universe's grand show. In the grand scheme of things, we're just stardust witnessing the cosmic dance of galaxies. And isn't that a humbling thought?